Have you ever looked at your hand, a glass of water, or even the air you breathe, and wondered, what is this really made of? I mean, what is the fundamental stuff that makes up everything in the universe? It's one of the oldest questions humanity has ever asked. And today, we're going on an incredible journey to answer it. We're going deep, deep down into the very heart of matter. Let's start with something familiar, like this apple. If I were to cut this apple in half, and then in half again, and keep cutting it into smaller and smaller pieces, how far could I go? Would I be able to cut it forever? The ancient Greeks debated this very question. A philosopher named Democritus proposed that if you kept cutting, you would eventually reach a tiny indivisible particle he called an atomos, which means uncuttable. He was astonishingly close to the truth. For centuries, this was just an idea. But fast forward to the 1800s, and a scientist named John Dalton revived the concept with his atomic theory. He proposed that all matter is made of these tiny particles called atoms, and that atoms of a specific element, like gold or oxygen, are all identical. This was a revolutionary idea that laid the groundwork for modern chemistry. We learned that the water we drink is made of hydrogen and oxygen atoms bonded together. The air we breathe is mostly nitrogen and oxygen atoms. You, me, this desk, this camera, we are all just massive collections of atoms. So, is that the end of the story? Are atoms the final uncuttable building blocks? Not even close. This is where things get really interesting. In the late 19th and early 20th centuries, scientists discovered that the atom itself has a structure. It wasn't a solid, indivisible ball after all. Think of it like a miniature solar system. At the center is a dense core called the nucleus, and zipping around it are even tinier particles called electrons. The electron was the first subatomic particle to be discovered. It's incredibly small and has a negative electrical charge. For a while, scientists thought the atom was like a plum pudding, with negative electrons scattered inside a blob of positive charge. But an experiment by Ernest Rutherford changed everything. He shot tiny particles at a thin sheet of gold foil and was shocked to see that while most passed straight through, some bounced right back. This could only mean one thing. The atom was mostly empty space, with a tiny, dense, positively charged nucleus at its center. So now our picture has evolved. Matter is made of atoms, and atoms are made of a nucleus and electrons. The nucleus itself contains two types of particles: protons, which have a positive charge, and neutrons, which have no charge at all. The number of protons in an atom's nucleus is what defines it as a particular element. An atom with one proton is hydrogen. An atom with 6 protons is carbon. An atom with 79 protons is gold. The electrons are held in orbit around the nucleus by the electrical attraction between their negative charge and the proton's positive charge. It's an elegant, beautiful system. For a long time, protons, neutrons, and electrons were considered the fundamental particles, the absolute rock bottom of reality. But physicists are a curious bunch, and they couldn't resist asking, what if we could smash these particles together with incredible force? What would happen? So, they built giant machines called particle accelerators, like the Large Hadron Collider at CERN. These incredible devices use powerful magnets to accelerate particles to nearly the speed of light and then smash them into each other. And what did they find when they looked at the debris from these high-energy collisions? They found that protons and neutrons shattered. This meant they weren't fundamental after all. They are made of even smaller particles. Welcome to the world of quarks. That's right, quarks. It's a funny name, taken from a James Joyce novel, but these particles are serious business. There are 6 different flavors of quarks. with whimsical names like up, down, charm, strange, top, and bottom. A proton, for example, is made of 2 up quarks and 1 down quark. A neutron is made of 1 up quark and 2 down quarks. These quarks are glued together by an incredibly powerful force, appropriately called the strong nuclear force. The particle that carries this force is called a gluon. Think of it as the cosmic superglue, holding the nucleus of every atom together. So, let's recap our journey. We started with an apple. We zoomed in past what our eyes can see, to the level of atoms. Then we dove inside the atom to find a nucleus made of protons and neutrons, surrounded by electrons. Then we cracked open the protons and neutrons themselves to find the truly fundamental quarks, held together by gluons. As far as we know today, quarks and electrons are fundamental particles. You can't break them down any further. They seem to be true points in space, with no internal structure. This complete picture of fundamental particles and the forces that govern them is called the Standard Model of Particle Physics. It's one of the most successful scientific theories ever created, accurately describing almost every experiment we've ever been able to perform. It tells us that everything you see, everything you touch, everything you are, is made from just a handful of these fundamental building blocks. A few types of quarks, and a particle called the electron. All the incredible diversity of the universe, from stars and galaxies to puppies and pizza, arises from the different ways these few simple ingredients are combined and interact. It's a mind-bending thought, isn't it, that the solid chair you're sitting on is actually more than 99.99999% empty space. The reality you experience is a dance of energy fields and quantum particles, governed by a set of elegant underlying rules. The journey from wondering about an apple to discovering the existence of quarks is a testament to human curiosity and our relentless drive to understand the cosmos. And the quest isn't over. Scientists are still pushing the boundaries, exploring mysteries like dark matter and dark energy, which seem to make up most of the universe, but aren't part of the Standard Model. What are they made of? Are there even more fundamental particles waiting to be discovered? The adventure of science continues. So next time you look around at the world, remember the incredible, invisible reality hiding just beneath the surface. You are living inside a magnificent cosmic construction, built from the tiniest of pieces. Thank you so much for joining me on this deep dive into the fabric of reality. If you found this as fascinating as I do, please hit that like button and consider subscribing for more journeys into the world of science. Let me know in the comments what you'd like to explore next. Until then, stay curious.